Hello friends, welcome to this online refresher course in education under ARPIT 2019. The title of this course is Concerns in Educational Research and Assessment. I am Kaushal Kishore from School of Education, Central University of South Bihar, Gaya. I am extending my greetings to you all on behalf of National Resource Center for Education, that is NRC for Education, Central University of South Bihar, Gaya. The present discussion is on a very interesting and important topic faced by every researcher in the field of education. Not only the field of education, it is faced by almost all the researchers in all disciplines. And the topic of today's discussion is hypothesis. Some concerns. The topic hypothesis in itself is very interesting as well as controversial in some sense. Why I am saying so? Because many literature say different things about hypothesis. That's why it is necessary to discuss these differences and these concerns while going for research. In this session, it is expected that after going through this session, you will be able to recall the concept of hypothesis, describe the characteristics of research hypothesis, differentiate between research hypothesis and null hypothesis. You will be able to explain various types and forms of hypothesis, that is very important, and formulate various hypotheses in your research. So now let us start our discussion. Let us understand what is hypothesis. Best and Kahn say that the two important functions that hypotheses serve in scientific inquiry are the development of theory and the statement of parts of an existing theory in testable form. Snow in 1973 described 6 levels of theory, with first hunch based on theory, past experiences, observations and or information gained from others. A hypothesis is formulated in such a way that this hunch can be tested. Based on the findings of the subsequent research, the hypothesis is supported or rejected, and more hypotheses are formulated to continue the process of building a cohesive theory. What does it mean? It means we formulate some hypothesis, we keep on testing these hypotheses, and if one hypothesis is rejected, we formulate another hypothesis, then we keep on testing it, and then we decide either we reject it or we retain it. If we retain it, that's okay. Otherwise, we reject it and move on to the new hypothesis and to test it. Best and Kahn further say that the most common use of hypothesis is to test whether an existing theory can be used to solve a problem. In everyday situations, those who confront problems often propose informal hypotheses that can be tested directly. For example, when an electrical appliance fails to work and switch is turned on, several hypotheses come to mind based on our understanding of electricity and on our past experiences with that appliance. And what are these hypotheses? These may be that the plug is not properly connected to the wall outlet, or the motor is burned out, or the fuse is burned out, or the circuit breaker has been tripped, which we commonly say MCB, or there has been a power failure in the area. Each of these speculations can be tested directly by checking the plug connection, substituting a motor known to be in working condition, inspecting the fuse or circuit breaker, or noting whether other lights in the house or in the neighborhood are on. Accordingly, we can test all our hypotheses which we framed related to this electrical appliance, and we can test them directly and reject them if they are not correct. Thus, we formulate and test hypotheses. Also, in our educational researches, we formulate research hypotheses and test them. The research hypothesis is also named as scientific hypothesis. According to Wiersma and Jers, a hypothesis is a conjecture or a guess at the solution to a problem or the status of the situation. It is a conjecture or proposition about the solution to the problem, the relationship of two or more variables, or the nature of some phenomena. According to Best and Kahn, the research or scientific hypothesis is formal, affirmative, mind it, affirmative, not negative, not interrogative statement predicting a single research outcome. It is a tentative explanation of the relationship between two or more variables. Here, it is important to note that Best and Kahn are saying that a research hypothesis or a scientific hypothesis is an affirmative sentence, affirmative statement. You recall when you learned about English grammar, you learned about three types of sentences. One is affirmative sentence, another is negative sentence, another is interrogative sentence. In affirmative, we directly state something. In negative sentence, we negate something. In interrogative, we question. We put questions. In research hypothesis, the statement is an affirmative statement. So, it is pertinent to mention here that sometimes some people say, not all, some people say that I can frame my hypothesis in question form. Best and Kahn are negating this idea. They are saying that research hypothesis is an affirmative statement. If it is an affirmative statement, it cannot be an interrogative sentence. It means I cannot frame my hypothesis in question form. Moreover, if a research hypothesis is a tentative solution, it is not a question, it is a tentative solution. That's why they say that research hypothesis is an affirmative statement. Additionally, they are saying that it is not negative sentence. If some people say that in my research I am framing only null hypothesis. Null hypotheses are framed for other purpose. We will discuss this thing in this session ahead. But mind it, null hypothesis is not research hypothesis. Research hypothesis is an affirmative statement, whereas null hypothesis is a negative statement. So, it is important to mention that the definition given by Best and Kahn is removing many confusions here. Now, let us move towards characteristics of a hypothesis. Let us understand what are the important characteristics. Number one, a hypothesis is an academic guess. It is not a wild hunch. And again, it is very important thing. They are saying that hypothesis is an academic guess, not a wild hunch. Academic guess means it is based on some academic reasons. You cannot say I can frame any hypothesis and if it is wrong, it will be rejected. No. You cannot make a wild hunch. there should be a definite reason for the hypothesis, either from theory or from some evidence that is the useful and valuable hypothesis. A hypothesis should always explain what you expect to happen. It must be clear and understandable. It must be testable. It must be measurable. Typically, a hypothesis states a relationship or effect between variables, and this should be done in as straightforward and in a clear manner as possible. A hypothesis should be testable, and for this hypothesis to be testable, the variables must be operationally defined. That is, the researcher specifies what operations were conducted or tests used to measure each variable. That is why it is important in research to define the variables operationally. If you recall from your research experience that in our research we define our variables theoretically as well as operationally. Theoretical definitions are conceptual definitions of a particular variable, whereas in operational definitions we define how am I going to measure this variable in my research. And that is the same thing they are saying, that if I am framing a hypothesis, a research hypothesis, then it must be testable, and if the research hypothesis is testable, the variables used in this research hypothesis must be defined operationally. Thus, the hypothesis focuses the investigation on a definite target and determines what observations or measure are to be used. Wiersma and Gers discussed that a weakness of many hypotheses is that they are too broad to pinpoint the specific problem under study. For example, they are giving an example here that bright students have good attitude towards school. Here in this hypothesis, the term bright, good and attitudes represent types of broad, undefined generalities. Sometimes a vague relationship between brightness and good attitude is implied here, but little direction for research is provided. That's why this hypothesis is not considered as good hypothesis. It is too broad. To convert this statement or this hypothesis into an acceptable hypothesis, it might be changed to read that students aged 9 through 11 who score in the upper 25% of their class on the standardized IQ test have a higher mean score on the XYZ attitude towards a school inventory than students who score in the lower 75% of the class on the IQ test. Now this statement, which we converted into this hypothesis, is in testable form, and it is specific. It is not too broad, and it is giving a clear-cut direction towards the research, how to go ahead, how to proceed. It is very clear from this statement now that we have to conduct that particular aptitude test, we have to conduct an IQ test, we have to get that percent basis division of the students, and so on. Note that this statement has specificity, and that is, it states an expected relationship, that is the upper 25% on the IQ test have higher mean attitude score, lower 75% on the IQ test. Assuming that the measurement can be made, the hypothesis is testable. Another version could be, for this statement, a positive relationship exists between the scores on the specific IQ test and the specific attitude inventory for students aged 9 through 11. These both are correct hypotheses, though the way to proceed or way to measure and way to analyze will be different in both the cases. Here in this statement, the hypothesis is shorter than the initial statement. It includes an expected relationship and it is testable. In both instances, the hypothesis contains the operational definitions of the variables involved. Academic aptitude, that is brightness actually, and attitude towards school. These variables are defined by scores on a specific test and a specific inventory. If the operational definitions make the statement of the hypothesis too cumbersome, they can be presented in a separate statement or section. However, the variables should be clearly identified so that the expected relationship is defined. That is, that it will be positive or that the mean of a certain group will be higher than of another group. The hypothesis is testable, that is, procedures exist for analyzing the data that will give results either supporting or refuting the hypothesis. Best and Kahn also support this and say that in the behavioral sciences, the variables may be abstractions that cannot be observed. These variables must be defined operationally by describing some sample of actual behavior that are concrete enough to be observed directly. And that is the way we define operationally the variables. The relationship between these observable incidents may be deduced as consistent or inconsistent with the consequences of the hypothesis. Thus, the hypothesis may be judged to be probably true or probably false. For example, one might propose the hypothesis that 9th grade children taught using cooperative learning method would have different achievement than those taught using the traditional method. Children, in this case, children assigned to two groups, one taught by using cooperative learning, that is experimental group, and the other using the traditional method, that is control group. The experiment would be carried out, say, for a period of 3 months. If the hypothesis were true, the mean of experimental group on a standard achievement test would be significantly different than those of the control group. Now, let us understand various types and forms of hypothesis. Kerlinger and Lee in 2000 indicate that in a broad sense, researchers use two types of hypothesis that are substantive and statistical. Substantive hypotheses, sometimes called research hypotheses, are tentative statements about the expected outcomes for the variables of the research study. An example of a substantive or research hypothesis may be like laboratory instruction enhances the student's understanding of scientific processes over an instructional approach limited to lecture, discussion and theoretical problem solution only. Notice that the research hypothesis is a directional hypothesis here. That is, it indicates the expected direction of the results. And this direction is implied by theory of previous research. The hypothesis would not indicate the expected direction of the results in exploratory studies, where there is no strong rationale for an expected direction. When it is time to test whether the data support or refute the research hypothesis, it needs to be translated into a statistical hypothesis. A statistical hypothesis is given in statistical terms. Technically, in the context of inferential statistics, it is statement about one or more parameters that are measures of the population under study. Statistical hypotheses often are given in quantitative terms. For example, the mean achievement of the population of 9th grade students taught by method A, say cooperative learning method, differs than the mean achievement of the population taught by method B, say traditional method of teaching. Let us understand the general form of a statistical hypothesis. As Wiersma and Gers say, firstly, they are concerned with populations. Though we use inferential statistics to draw conclusions about population values as we have access to only a sample of participants. We may have only 50 students, say in method A, that was cooperative learning, and 50 students in method B, that was traditional method of teaching, in our research study. But if the students are randomly representative of the population of 9th graders, our conclusions can be statistically projected to all 9th graders. In order to use inferential statistics, we need to translate the research hypothesis into a testable form, which is called the null hypothesis, and to generate an alternative hypothesis. An alternative hypothesis indicates the situation corresponding to when the null hypothesis is not true. The stated hypothesis will differ depending on whether or not it is a directional research hypothesis. How? We will discuss it ahead. First, let us see what null hypothesis is. At the beginning of our study, we state an affirmative scientific or research hypothesis as a prediction of the outcome that we propose to test. Most often, this research hypothesis suggests that a difference of some kind will occur. Like, if I am going to test difference or I am going to test effectiveness of a new method, say method A, that is cooperative learning method, over a traditional method of teaching, say method B, on 9th grade students in a particular subject, say science achievement, then my research hypothesis will state that there will be a significant difference in science achievement of 9th graders taught by method A than taught by method B. Later, at the stage of the statistical analysis of the observed data, we restate this hypothesis in negative or null form. For instance, the previously stated hypothesis that 9th grade children taught using cooperative learning method would score differently on a specified test of achievement than those using the traditional method would be restated like, there is no significant difference between the achievements of the two groups. The null hypothesis relates to a statistical method of interpreting conclusions about population characteristics that are inferred from the variable relationship observed in samples. The null hypothesis asserts that observed differences or relationships result merely from chance error inherent in the sampling process. That's why it is saying there is no significant difference between these two groups. This way, till now we have discussed that there are two types of hypothesis. One was substantive hypothesis, another was statistical hypothesis. In substantive hypothesis, we said that it is a research hypothesis, and in research hypothesis we discussed that it is an affirmative statement. When we convert our research hypothesis into testable form, that is null hypothesis, then we set our research hypothesis as an alternative to this null hypothesis. My research hypothesis may be stated in two ways. One is non-directional way, another is directional way. So let us understand what is non-directional way or non-directional research hypothesis. The null hypothesis states that the population parameter equals some value, say 100. That the corresponding non-directional research hypothesis states that the population mean does not equal to 100. Note that this allows for the population mean to be greater than 100 or less than 100. It is simply saying that the population mean is not equal to 100. It is not fixing or indicating a direction. Let us see another example illustrating a non-directional research hypothesis when two group means are compared. The case we just discussed, teaching of students by two methods, that one was cooperative learning method, another was traditional teaching method. The null hypothesis would be the mean achievement of the population of 9th grade students taught by method A, that is cooperative learning, equals the mean achievement of the population taught by method B, that is traditional method. Whereas non-directional alternative hypothesis in this case would be the mean achievement of the population of 9th grade students taught by method A, that is cooperative learning, does not equal the mean achievement of the population taught by method B, that is traditional teaching method. The another way of stating my research hypothesis is directional research hypothesis. Using a directional research hypothesis requires some small but important changes. The alternative hypothesis indicates the direction of the expected result, and the null hypothesis all other possible outcomes. Now consider the earlier example when the null hypothesis was that the population mean is 100, and we framed non-directional alternative hypothesis that population mean is not equal to 100, and we didn't fix whether it's more than 100 or less than 100. Now the research hypothesis in this case, that is directional hypothesis, would be that population mean is greater than 100. Obviously, if my academic background, my review indicating that it must be more than 100, then I will state population mean is greater than 100, or if my review or my theory is stating that it must be less than 100, then I will state population mean is less than 100. In both the cases, it will be a directional hypothesis. Now, in this case, when I am framing my research hypothesis as directional hypothesis and saying that population mean is greater than 100, the null hypothesis would now that the population mean is equal to 100. It is negating which is stating in directional hypothesis. Let us see another example presenting the hypothesis in directional form. And let us take the same example when we were comparing group means of two groups for two different teaching methods. In this case, the null hypothesis would be the mean achievement of the population of 9th grade students taught by cooperative learning method equals the mean achievement of population taught by method B, that is traditional teaching method. Whereas the alternative hypothesis in this case, when I decided directional research hypothesis would be the mean achievement of the population of 9th grade students taught by cooperative learning method is greater than the mean achievement of the population taught by traditional teaching method. The null and alternative hypothesis include all possible outcomes of the research study. In combination, the mean for the method A may turn out to be equal to, greater than or less than the mean of method B, and the statistical hypothesis allow for any of those outcomes. Now, before moving to some more examples of hypothesis and their alternative form, let me summarize or conclude here that we understood that there is a research hypothesis which we can state depending upon the literature or the academic background or the theory in directional form or non-directional form, and to test it we convert it into a null hypothesis, which is also known as a statistical hypothesis. And when we test a null hypothesis, we keep our research hypothesis as an alternative, and that time this research hypothesis is known as alternative hypothesis. So research hypothesis or alternative hypothesis may be directional or non-directional, and the second type is the null hypothesis or the statistical hypothesis, which we test. We test null hypothesis and take a decision about this research hypothesis or the alternative hypothesis. If we reject null hypothesis, we accept our alternative hypothesis because we keep these two hypotheses in such a way only one out of these two is true. Either null hypothesis is true or the alternative hypothesis is true. If I reject my null hypothesis. Alternatively, I accept my alternative hypothesis, which is actually the research hypothesis. And if I do not reject it, I cannot reject it, I retain this null hypothesis, I do not accept my research hypothesis or alternative hypothesis. But here one thing is very important to note, that as I said, I am going to state my research hypothesis in directional form or non-directional form. It is not decided by the researcher only. What do I mean here? I am saying that it is not depending upon the researcher's thinking. I am thinking that it must be directional, so I should frame a directional hypothesis. I am thinking that it must not be directional, so I am framing non-directional hypothesis. No, it is not like that. The decision of framing my research hypothesis in directional or non-directional form is taken on the basis of academic background or existing theory or my review. Accordingly, I decide, and it affects ultimately my null hypothesis testing. We will discuss in another session in inferential statistics that if I frame directional hypothesis, then I use one-tailed testing in my inferential statistics. Whereas if I frame non-directional hypothesis, then I use two-tailed test. And using one-tailed test or two-tailed test creates difference. And if it is not used properly or if it is used wrongly, it leads to error. Type 1 and type 2 error are also related to it in a way. We will discuss these things in detail, but for your information only, if I had framed directional hypothesis in place of non-directional hypothesis, my literature was suggesting framing non-directional hypothesis, but I framed directional hypothesis as my research hypothesis, and then I tested my null hypothesis and I used one-tailed test. Actually, I am committing type 1 error. If my research requirement was of framing directional hypothesis and I framed non-directional hypothesis, then while testing I used two-tailed test, I am committing type 2 error. So it is very important to decide which kind of hypothesis I have to frame in my research, whether directional or non-directional. Okay, now let us see some more examples of hypothesis and their alternative forms. Say there is a null hypothesis, the academic achievement of high IQ students equals that of average IQ students. Or I can say it in this way, that there is no difference between the academic achievement of average and high IQ students. In this case of null hypothesis, my alternative hypothesis would be the academic achievement of high IQ students is not equal to that of average IQ student. Or I can say there is difference between academic achievement of high IQ students and average IQ students. And notice that this alternative hypothesis is non-directional. Another example, my null hypothesis would maybe that there is no difference in achievement of boys and achievement of girls in a particular class. In this case, my alternative hypothesis would be there is a difference between achievement of boys and achievement of girls in a particular class. Again, this is a non-directional hypothesis. One more example, yoga does not affect anxiety. This is a null hypothesis. And my alternative hypothesis may be yoga reduces anxiety. It is a directional hypothesis now. One more example, intensive coaching enhances reading skills. This is a directional hypothesis. And the null form for this would be there is no effect of intensive coaching on enhancing reading skills. The last two examples which I discussed just now, one was yoga, another was intensive coaching, were related to directional hypothesis. Now let me continue the question, should hypothesis be stated in directional or non-directional form? or does it make any difference? The form used should be determined by the expected results, as I discussed just now. If the research literature in the area indicates that we can expect a difference or a direction of results, a directional hypothesis is called for. If the research literature does not present convincing evidence for a direction, or if an exploratory study is being done, a non-directional hypothesis should be used. And this is in tune with which just 5 minutes before I said that we should not decide by our own that we should frame directional or non-directional hypothesis. Though this is important that we should frame our hypothesis on the basis of research literature or theories, there are some different opinions as well. Thus, we should decide on the basis of these things which kind of hypothesis should I frame in my research. Wiersma and Joss say that because of the emphasis on null hypothesis in inferential statistics, educational research and behavioral sciences research in general has probably overused the non-directional hypothesis and underused the directional hypothesis. And obviously, this is because of that, if I frame directional hypothesis, I am committing type 1 error. And I want to avoid type 1 error, so I am not framing directional hypothesis, I am simply saying if there is not strong evidence, I am going for non-directional hypothesis, and this is a very common trend in our research, particularly in educational research. Though personally I feel there is no problem with it. Most hypotheses are the opposite of the null hypothesis, that are alternative hypotheses. And in such a case, if the researcher rejects the null hypothesis, he or she accepts the research hypothesis, concluding that the magnitude of the observed variable relationship is probably too great to be confused with sampling error. It means that the difference is not due to sampling error or by chance. It is sufficient enough to be concluded as the real difference. Thus, to conclude, we may say that statistical hypotheses are used in the analysis of data. Substantive or research hypotheses indicate the direction of results, and hypothesis may be stated in directional or non-directional form. The null hypothesis is the hypothesis of no difference or no relationship. Kindly note that these comments about hypothesis apply more to quantitative research than qualitative research, as Wiersma and Joss discuss that in quantitative research, hypotheses typically are identified at the beginning of the research study prior to data collection, and if modified, such modification is minimal. On the other hand, hypotheses in qualitative research are much more likely to emerge as the research is being conducted. There may not be some tentative general hypothesis at the outset, but qualitative researchers are very willing to add, delete, modify and refine hypotheses as data are collected and analyzed. Hypotheses in qualitative research are conjectures, but there is not much concern whether they are directional or null hypothesis. Their wording fits the context of the phenomena under study. For example, an ethnographic study of the school environment of different socio-economic background students to determine factors related to potential dropout. Then the tentative reasons may be listed as, which we commonly call hypothesis, interaction among students of different socio-economic background during instruction. That may be one of the reasons. Second reason may be a role of the teacher in enhancing student learning. Third reason may be opportunity for student success in the academic subjects. Kindly note that these listed reasons do not specify anticipated results. Essentially, they identify factors for the researcher to observe as the research gets underway. Although hypotheses have an important role in educational research and they appear in many studies, all research is not done for the purpose of testing hypotheses only. Sometimes, especially in exploratory studies, the nature and characteristics of the data are analyzed without specific hypothesis. In some research, population values may be estimated rather than tested or for specific hypothesis about these values. We are simply going to establish the population value. That's why we are conducting research. We don't want to reject or accept the hypothesis. One more example may be that suppose a question in a research study is, what is the average performance level of young adult male on text ABC? If a sample of young adult males is tested, the sample data would be used to obtain estimate of population average, that is population parameter, rather than to test a specific hypothesis about that average. Here we are not going to test any hypothesis stating about the population average. Rather, we are just trying to establish or drawing inference about the population average on the basis of performance of that selected sample. Let us see some examples of hypotheses related to problem statements. A statement of a research problem may have one or more, usually more, hypotheses associated with it. Hypotheses are formulated from the research problem statement and should follow directly from it. Ethnographic research takes a holistic and descriptive approach rather than a cause and effect approach. So we are not concerned about the distinction between independent and dependent variables in ethnographic hypothesis. There are not likely to be any control variables in ethnographic research, but there would be many uncontrolled variables, such as the elementary school background of the students in the problem of dropout, which we just discussed. Let us see a problem with its statement and the possible hypothesis and different variables. I am stating a problem here. The statement of problem is a study of the effects of two teaching methods, A and B, on the science achievement of 9th grade students in school X. This is my problem statement. And my hypothesis would be, with students, kindly note, I am not going to state a single hypothesis. As I just said, there may be different hypotheses associated with the problem. So I am stating some of the hypotheses. Number one, with students of heterogeneous prior science achievement, there will be no difference in the mean gains in science achievement for students taught by program A and those taught by program B. Second may be, for students scoring in the lower 30% on prior science achievement, those taught by method A will have a greater mean gain than those taught by method B. What does it mean here? The prior science achievement means here that maybe scores on pre-test, or we may take some other criterion, but on that criterion we are classifying students in certain groups, and I am stating this hypothesis for a particular group. In the same way, I can state one more hypothesis. For students scoring in the upper 30% on prior science achievement, those taught by program B, that was method B, will have a greater mean gain than those taught by method A. One more may be, for students scoring in the middle 40% on prior science achievement, there will be no difference in mean gains for students taught by method A and those taught by method B. These different hypotheses is actually drawn on the basis of my review of the literature or previous studies or the theory. In the same problem, the operational definitions may be like individuals. Who are the individuals? So the operational definition is individuals are all 9th graders of school X. The operational definition of method A is cooperative learning method, and particularly STAD developed by Slevin. Method B, traditional teaching method. In the research, independent variables are teaching methods that are A and B. One was cooperative learning, another was traditional teaching method. Dependent variable of the study are gain score in science achievement. For example, the difference between scores on two forms of a standardized achievement test. One form given prior to the study, the second form given after the study. If I am going to use a same test as pre-test and post-test, then there is no need of two forms. I can say the scores on the same test prior to experimentation and the scores on the same test after experimentation. In the research, possible moderator variables would be teacher, teaching style, learning style, student scholastic ability, etc. The possible control variables would be prior achievement score, gender of the students, etc. There is one more concern here. In hypothesis, should we use words significantly when describing the relationship? Actually, if we are referring to statistical significance, we should use the word significant when talking about results from a sample that is taken from a population, and you should not use the term when talking about results for a population. Wiersma and Jers argue that hypotheses are written about the populations. So the researchers should not use the word significantly in research hypothesis. However, while using inferential statistics, we should use the term significant. That's why when we state null hypothesis to test using inferential statistics, we use term significant difference. So friends, in this session, we have discussed concept of hypothesis, characteristics of research hypothesis, difference between research hypothesis and null hypothesis, types and forms of hypothesis, framing various hypotheses, etc. This is all about this topic for now. I hope that you have enjoyed the session. Thank you for watching this video. Namaskar.